Hello there. Today we're going to go through a Jupyter Notebook example where we're going to build a text classification model on TensorFlow and deploy it to Algorithmia. The notebook example that we're going to go through can be found on GitHub under algorithmia.io/model-deployment. When you run Jupyter Notebooks, you can basically run them on multiple different places. They can run on a server somewhere. You can even run this Jupyter Notebook on Google Colab. But for our demonstration, we're going to run it locally on our machine. And to be able to do that, the first thing we need to do is go ahead and set up a new virtual environment using Python 3.6. And then we're going to go and activate our environment. And fortunately, every single notebook example in our repository comes with a requirements.txt file that has all of the packages we need for our example. And you can go ahead and install it using pip install-r requirements. So while our packages are being installed, we're going to kind of go ahead and start with the next step, which is to go ahead and create a new API key. API keys are needed to be able to call your algorithms, manage your algorithms, and like everything in between. To be able to call your, to be able to create a new API key, all you have to go to is your profile page. Under your profile page, there's a API keys tab. You can go ahead and click on the Create API Key button. We're going to call this API key Jupyter Notebook. We're going to also give our API key read and write access to the data API. This is because we're going to upload our model file and host it on Algorithmia, so we need to be able to write our file. And last but not least, we're going to enable this API key to manage our algorithms, which basically can create new algorithms from scratch, update them, and delete them. So once we create our API key, all we have to do is go ahead and copy this. So as you can see, our packages are installed. All we have to do from this point on is to invoke Jupyter Notebook, and that's going to run our Jupyter server. And as you can see, we're going to see all of our files where Jupyter Notebook was initiated. We're going to go ahead and click on our Jupyter Notebook example. So we're going to see the same exact notebook we saw on GitHub here. The only difference being it's now showcasing that inside of our Jupyter Notebook server. So since we're running this locally, we can skip this first step that uses pip install to install all of our dependencies. We already did that in our virtual environment. All we have to do now is go ahead and update our API key. And you can go ahead and update your username. In my case, my username is B, and you can also define a algorithm name. This is basically a namespace. Since we're going to train a text classification example on the IMDb movie data set, we're going to go ahead and call our algorithm movie review sentiment. So let's first run that. So let's go ahead and import TensorFlow to make sure that TensorFlow is installed successfully. Let's go ahead and download the IMDb dataset. So we're going to go through a data exploration phase to see what our dataset kind of looks like and whatnot. So as you can see, we have 25,000 training examples with the corresponding 25,000 labels. If we look at the first example and print that out, you can see it's actually just a big vector. If we compare the vector length of the first movie review with the second movie review, we can see that they're not fixed length. This is kind of an issue for training models in general, because unfortunately models, generally speaking, expect a fixed variable size. So if it's 256, it always expects 256. Fortunately, there's a quick way to solve that, and we'll fix that in a few moments. So before we can go ahead, we also want to make sure that the review itself is actually a movie review, right? This is a vector, and there's no direct way to make sure this is actually a review. So fortunately, our data set also comes with a word index. It's basically a dictionary that maps every single one of these numbers to a word. And if we basically convert our first movie review back from a vector, we can actually see it is a real movie review. So We're going to also go ahead and fix the length of these vectors to 256. If the vector is smaller than 256, we're going to pad it with zeros until it hits 256. If it's bigger than 256, we're going to cut it off essentially. And as you can see, we've basically padded our movie review over here. So we're going to now go ahead and build our model. You can get your model summary just by calling the summary method, and then we're going to go ahead and build our model, and then we're going to create a validation data set, and we're going to go ahead and start training our model. Training should be pretty quick since we're only training on 40 epochs. And as you can see, our loss is decreasing, our accuracy is increasing, and what the value we're more interested in here is our validation accuracy and loss. So if we go all the way to the bottom, we can see our validation accuracy stopped at 88.49% with a loss of 0.3. So we're going to go ahead and evaluate our model actually on our testing data set this time, and we have a final accuracy of 87.33% with a loss of 0.32. So we also want to see how our model performed over time, and we're going to use matplotlib to plot the training loss and then the validation loss with the training accuracy and the validation accuracy. The next step after training your model is deploying it to Algorithmia. Since earlier in the notebook we already defined our API key, our username and algorithm name, we're kind of skipping those steps over here, but we're going to go ahead and define a data collection. This is basically where we decide where our files will live, including our model file. So the syntax is basically starts with data / .my refers, it's an alias, it refers to my username, and then you can give it a name. So in this case, we're going to call our data collection my collection. So with that, I'm going to also go create an Algorithmia client. And I'm also going to tell my client if my data collection does not exist, I want you to go ahead and create it. We're also going to go ahead and create a local directory called algo. This is where we're going to basically keep all of our files and develop our algorithm. So fortunately, Keras and TensorFlow comes with a very simple method to save our models. Basically, the method is called .save. So we're going to serialize the model locally, and then we're going to go ahead and upload it to the data collection on Algorithmia. We're going to upload it to the data collection we just created earlier. And it's fairly simple to upload files to Algorithmia. The syntax follows as client.file. You define where your file lives locally, and then, you define where your file lives on the data API, and then when you call put file, you define your file where it lives locally. So it's fairly simple to go ahead and do that. And then after that, we're going to go ahead and upload our word index. We kind of need that because we need our word index so we can convert text back into a vector, because our model is going to be expecting a vector to make a prediction, a classification, right? So we're going to also go ahead and basically define our algorithm. An algorithm can have at minimum have a summary, a label, and a tagline. Since this is a sentiment analysis classifier for movie reviews, we're going to go ahead and fill out all of the definitions. Since we're running on TensorFlow 1.12, we're going to select this package set. It's basically an optimized Docker container for our use case. And then we're going to go ahead and create our algorithm. Once we successfully create our algorithm, we're going to get this JSON response back. So we're going to go ahead and git clone our algorithm locally. Basically, every algorithm on Algorithmia is also a Git repository. And the structure of these algorithms kind of look like this. So whatever your algorithm name is, that's going to be the root directory. Under that, we're going to have a source folder. And inside of that, we're going to have our main algorithm file, our test file. And in the same parent folder, we're going to also have our requirements.txt file that we're interested in. So the requirements.txt file basically keeps all of our Python dependencies, and the algorithm.py file is where our algorithm actually runs. So we already uploaded our model file, but basically our algorithm doesn't know what to do with this model file. all we have to do is now write our algorithm that can load the model in memory and then run the algorithm. So we're going to write our algorithm file actually here in our Jupyter notebook. Fortunately, it allows you to write files. So the first thing we need to import is Algorithmia. So we can create our client to download our model files. We're importing Keras to load our model. We're going to need NumPy and Pickle for our use case over here. So since we uploaded our model file, we first define where our model file lives on Algorithmia. Again, we're using the same syntax, data//.my collection, and then this was the model file name we used. And then we're also going to download our word index. So again, it's fairly simple to download files using a similar syntax, client.file. You define where your file lives on the data collection, and then you just say get file, and then that will literally return a file handler. And then if you call the .name attribute, that will give you the absolute path to the file on the local machine. So once we have our model file, we go ahead and tell Keras to load that model into memory, and then now we have a model instance inside of our algorithm. We're going to kind of do the same thing for a word index. Earlier we pickled it, so we're going to unpickle it and load it into memory. And last and not least, since our model file expects a vector, we need to be able to vectorize our text. This is also where we're using NumPy, where we imported here earlier. Basically, it's going to go and take the text and then vectorize it, and then it's going to make sure that the length of the vector is 256. So we're also defining an apply function here. On Algorithmia, when the platform basically runs your algorithm, it expects an entry point in your algorithm file, and that entry point is just an apply function. So when someone calls your algorithm and sends you an input, it gets routed to this function, and whatever this function returns, it gets routed back to the user. So from the user's perspective, we're just going to expect a text. We're going to vectorize that text. We're going to pass that vector to the model, calling it the .predict method, and then we're going to return that back to the user. But because the returned value is a NumPy float value, that's not a Python primitive, we need to cast that to a normal Python float and then return that back to the user. The reason we do this is because the JSON serializer is not smart enough to handle different type of data structures. So after running this, we're going to go ahead and also define our dependency file, which has our TensorFlow -GPU installed. And then all we have to do is a git add, git commit, and then a git push. So when you git push stuff back to Algorithmia, it actually goes ahead and compiles your algorithm, and if the compilation is successful, you should get a build successful message in your git progress. And once you get that message back, that actually means your algorithm is readily available behind an API somewhere in the Algorithmia cloud. So as you can see, we got the build successful message, which means we can now go ahead and call our algorithm. So to call our algorithm, we need the latest hash, and we get the latest hash, which is basically this, but you can also access that using the .algo.info version info get hash path. And then we're defining a function that can take any arbitrary input and call our algorithm. Again, calling algorithms on Algorithmia is fairly simple. Is client.algo. The algo is made out of your username / algo name, and then if you want, you can provide a version, a hash, whatever version you want to point to. And then you call the .pipe method, which provides the input, and in our case, our input is going to be this positive movie review. And since the algorithm earlier returned a prop field, we're going to return that back to the user. So as you can see over here, we're providing our input, we're passing that to the get probability function we defined over here, and we get back our probability. As you can see, we just made a call to our model file that actually ran on Algorithmia and took our input, vectorized it, passed it through the model, return that input back to us onto our machine here. So you can go through this process as many times as you want. Once you're satisfied with the development of your algorithm, your model, you can basically just go ahead and hit publish. When you hit publish, all it does is it goes ahead and creates a new endpoint with the same model file, same code, but behind a semantic version. And this ensures that you have versioning for your model files and different versions of your software. And instead of calling our algorithm using the latest hash, we can go ahead and call our algorithm using the latest semantic version. Again, we do a similar thing we did with our hash. We get our latest version, and then we basically go ahead and call our algorithm using the latest version.